Hello everyone, welcome to another video walkthrough for VanLab. This time we're going to play Hybrid. It's a great chain created by XCT, and the name hints us towards a mixed operating system environment, and indeed in this beautiful chain we are going to have both Linux and Windows machine, but this time the Linux machine will be domain joined. Okay, it's a very interesting concept. It's not very common, at least in CDF scenarios, but it's definitely worth knowing specific TTPs related to Linux domain joined machines in case you find them in a real life engagement. So without further ado, let's dive straight in. So I've already launched the Nmap report. Let me get there. Okay, it's hybrid. So we already have the Nmap report. We can see that we have a domain controller in the first IP. If the IPs are different, it's because I've reset the lab. And here we have a Linux machine that is running some mail protocols, and the interesting part is that we also have port 2049, so we have NFS available here, which could be used to find juicy information, escalate privileges, and many more. So right here, the first thing that we should do is to add this IP to our etc host file and go here to see what is going on there. Okay, we saw that we have port 18 port 443 open, and we have a round-tube webmail application here. Okay, it's PHP based. We can try admin password here. We can try to inspect a bit. It's a very common webmail application that you'll often come across. Okay, we have Nginx, we have Ubuntu operating system. As I mentioned, it's PHP based. Okay, so you can try and brute force it. If you want to brute force round-tube, you better use Hydra with the mail protocols rather than the login form, because many times it will not be done correctly. But before we decide to brute force, let's see if we have anything interesting in the NFS protocol. So right here we can see that we have a directory which is available for us. So let's go here and mount it to our directory here. So we're going to take the opt share directory and mount it locally to inspect it, see if we can find anything juicy here. Okay, so let's list. We do have a file here. Let's copy this. Okay, many times we'll find interesting information here. Let's extract it. And we can see we have two directories here. We have the etc directory and the opt. Now if we go to opt here, not this, opt, we can see that we have a search hybrid.vl, and we have to search here. So probably the domain controller has also the Active Directory certificate services installed. This could be a hint for a possible privilege escalation vector later on. But let's just keep that in mind for now, because our target, our first target, should be to gain access to the webmail, maybe the Linux host somehow. So let's inspect the etc. directory. Okay, we have a password file, and now if we inspect this, we can see that we have the 3W data here, service running the account, but we don't actually see anything else. For example, we don't see a mic account or something else. So this probably means that we will have domain accounts in there. Okay, domain accounts do not show up in the Etsy password file because they're not local accounts, they're domain accounts. Okay, so we might find domain accounts in the home directory, but currently we can't find anything here. Let's further inspect Etsy. Now, Dovecode and postfix seem interesting. Let's see postfix. Okay, it has main F. Let's inspect SSSD. Okay, and let's inspect Dovecode. Now here we have something interesting. If we open it, sorry, yeah, cat Dovecode users. We can see that we have two accounts there with credentials, with plain text credentials. Okay, and this right here looks like a domain account. Okay, it's interesting. So we should probably try, I'm sorry, a type error. We should probably see if this one is a valid domain account, because if it is, we have already breached the Active Directory installation. Peter Turner, we need a dot here, and let's place the password. Okay, unfortunately this one is not a valid set of domain credentials. Okay, you can see that we have a status login failure here, but let's try these credentials for the RoundTube mail. Okay, let's see again. Okay, and duckling 21. Alright, we're successful in here. That's interesting. Now let's see if we have any contacts here. Okay, we can see we have Peter Turner. We already have his credentials, which will probably work. And let's see what we have here. We have a new sent mail. It says new spam plugin. Hey Peter, I enabled RoundTube's junk filter plugin to help with the recent spam. Best Ed. Okay, probably Edward. Okay, so it's sent from admin. Ed is the admin. We should keep that in mind. He might be a high privileged user, which might be a good privilege escalation vector for the domain escalation later on. And he says he has enabled a RoundTube's junk filter. Okay, now you can see plugins right here in RoundTube. Let's inspect the about. We can see the RoundTube webmail version, and we might want to search for vulnerabilities here. And we can also see the plugins. Okay, we have a plugin for attachments, for UI of jQuery, and we have this, which is Marcus Junk. This is the plugin. So since this is a CDF scenario and nothing else comes up, let's try to search if it's vulnerable somehow. And yeah, sure as hell we find something interesting here. Okay, vulnerability in RoundTube's Market Jump plugin allows attacker a specially crafted identity mail to code the plugin. Let's try and find some more information here. This is in Chinese. Okay, let's take a look at that tweet. Twitter is often, unfortunately, it's not there anymore. Okay. So we have this article here which explains the vulnerability to this specific plugin, and the interesting thing here is that this vulnerability can get us remote code execution. Okay, the plugin can execute arbitrary code. So the affected devices is Runtube version 1.6.1, which we have, and the Marcus Junk plugin enabled. So probably we are great there. Okay, you can see the vulnerable configuration, the technical analysis here, and the fix suggestion, but we are going to focus on the technical analysis here. So it says where we can find the vulnerable code here, the faulty code, and it says the prerequisites to launch the attack. So it says here that this function is executed whenever an email is moved to a junk folder from a web app interface. Okay, so we need to move it to the junk folder. Okay, let's try to move it to a junk folder right here. And the vulnerability is right here in the identity email. Okay, so it requires a user that can change his email, and this can be done through the identities. Let's see, we have that option. So let's go to settings, identities, and let's for starters, let's try to say admin2. Okay, so we've successfully changed it. You can see it right here. Alright, and it says how we can launch this attack. A user's normal identity is this, but we can change it in this here. Okay, and instead of space, we used this right here. Now if you Google this, it's the IFS. So it's the internet field separator here. It's a special variable, okay, for scripting. Okay, we don't need to delve much in there. And what we can actually do is insert the command right here. Okay, and this will be processed by the email. So we can actually place our payload here, and if we move an email to a junk folder, this will result in remote code execution. Okay, so let's launch our burp suit and let's try to experiment with this vulnerability here. Okay, here it says it has a short, brief, but very intuitive explanation. Let's okay, the intercept, and let's launch it right here. So okay, let's something is probably wrong in here. Okay, let me check the proxy settings. Yeah, the proxy settings are wrong. The port is wrong here, because in Foxy Proxy I use, let me check again. Yeah, it's 8082. So we should probably change that here as well. Okay, and it should work now. Great. let's forward it. Okay, and let's stop in reception and go to HTTP history here. Okay, so let's try and again change our email address. Let's switch it back to admin. Okay, and here, all right, cool. So we have it right here. This is the request that allows us to change the email, and we can inspect here the response. So let's get that to the repeater because we really want to experiment with it a bit and see what it returns. So the problem here, if you read carefully that specific explanation, is that we cannot always see the result of the command execution, right? For example, here the proof of concept is to create test.txt file in the runcubes directory. But the problem is that we won't be able to verify if this file was correctly created because everything is executed to the server. It's not reflected back to us. Okay, the result will not return back to us. So in order to verify if we can actually execute a command, the best thing would be to use something that would give a call back to us. For example, in other remote code execution, we would try a who am I, all right, or a hostname command. But here we won't get any results back. So this is why we need to grab this. Okay, we need to grab this, and we could go here and say ping our IP address. Okay, of course, instead of spaces, we need to use the IFS right here. Okay, and we'll need to URL encode this. Okay, so we are going to try and ping our attack machine to see if we actually have our remote code execution. So let's go and say TCP dump, and let's filter for ICMP packets. Okay, so let's try and launch it. Okay, no errors were produced here. If we also go to the UI and refresh, you can see that no errors were produced here. Now this is the first requirement. Now, in order to trigger the attack, what happened here? Okay, I'm sorry. In order to trigger the attack, we need to mark an email as junk. Okay, so let's move it to junk and see if we get something back. Okay, it hangs a bit, which is good, but nothing so far. Okay, let's check this again. Admin. Okay. All right, let's try to craft our payload here. Okay, and let's try to. All right. And let's place the end here. Let's try this again. Let's try the URL. Let's try the URL and code this again. Okay, let's click send. No errors were produced as far as I can see. And let's go see if we can get the ping back. Okay, still nothing. Maybe this is the problem, although I don't think it should be, but let's try this again. Okay, cool. We needed to define the interface. So we get the ping back, which is encouraging because we already have confirmed that we have the remote code execution, okay? So right now what we need to do is craft an IS reverse shell. Okay, so let's go here and try this. Let's define this. Okay, let's copy it here. Of course, we need the IFS instead of spaces. And let's grab all of this and let's go here, paste it right here, and of course URL encode it. Let's see what happens here. Okay. Okay, now here we do have a problem. We do have a problem here. Okay, we get an error message, an invalid email address message. Okay, and the reason for that is that some of the characters that we are using here cannot be accepted in an email. For example, /, or this one, the arrow, may not be available here. So let's try and confirm that. If we go here to the identities, and let's try and say, let's correct that and say this one, yes, it's an invalid email address. So this character causes a problem. If we use a /, okay, / is accepted, but here the pipe character is problematic. So we need to find a way to overcome this obstacle, and we'll see now how we can bypass this problem to put a reverse shell in the email address and launch it.